This is topic 5, lesson 4, dividing by multiples of 10. So today we're going to talk about how you can use basic math facts to easily divide by multiples of 10. So we're going to kind of ease our way into dividing by two-digit divisors. And we're going to start by using multiples of 10 because most multiples of 10, like 10, 20, 30, 40, or in the case of 20, 20, 40, 60, 80, or in the case of 30, 30, 90, we can pretty much count by multiples of 10 of any number fairly easily because we know the basic math facts, right? 1 times 20 is 20, 2 times 20 is 40, 3 would be 60 because we know 3 times 2 is 6, 4 would be 80 because 4 times 2 is 8, and so on. And that makes this a little bit easier. It's a good way to start. And then what we'll talk about next is how you divide with two-digit divisors with any number. But if you learn it with multiples of 10, it kind of gives you a nice way to ease into it. So we're going to talk about dividing by multiples of 10. And our first example we're going to give you is 249 divided by 20. And our first thing we're going to do is, you should be able to predict this, is going to be to estimate. So what we did was we left our 20 the same, and we rounded the 249 to 240 because we looked at the 2, we looked at the 2, and we looked at the 24. And sure enough, we can leave that 24 the same because 24 is even. 24 is divisible by 2. So 24 divided by 2 is 12. And then 0 minus 1, 0. There's no zeros to annex. So we have 12. So we would know two things from our estimate. We would know that it's most likely going to be a two-digit quotient, and it's going to be close to 12. And we're going to do our usual steps. We're going to divide. We're going to multiply. We're going to subtract. And we're going to check. Those are our 4 steps. So we know we're going to start in the tens place because this is a two-digit answer. So a two-digit answer would go over the 4 and the 9 here. And we're going to think to ourselves, how many 20s are there in 24? Well, there's only 1. So 1 times 20 is 20. So we divided, we multiplied. Now we're going to subtract 4. And now we're going to check. And 4 is lower than 20. Okay. Then it says bring down the 1s and divide by the 1s. We're going to bring down the 9. And we're going to think to ourselves, how many 20s are there in 49? Well, 1 20 is 20, 2 20 is 40, 3 20s is 60. So 2 20s is 40. That sounds pretty good to me. And 3 20s is 60. That's too high. So I'm going to go with the 2. So we divided. We divided. Now we're going to multiply. 2 times 20 is 40. Then we're going to subtract. And now we're going to check. Sure enough, 9 is lower than 20. So I get an answer of 12, remainder 9. Now I'm going to check that against my estimate. Sure enough, and that's pretty close, right? I don't think I can get much closer to that. In fact, if you think about it, it starts to make a little sense, right? I get a remainder of 9. Let's look at what our answer's got. Yeah, it's got a 9 there, right? It's because makes sense, right? Because if 240 divided by 20 is 12, and we've got 9 extra on there, there's our remainder 9. So math there's normally something you can even make sense out of with math, so that's kind of interesting. So it checks with our estimate. And if we want to go back, we could go back and we could do 12 times 20. And I'm going to do this instead of doing this I'm going to think to myself as 12 times 2 is 24 plus 1 0. And then I'm going to add in the remainder. Sure enough, I get the dividend. So I can go back and even check my answer. So it looks good to me. Okay, so that's how you do this. You're going to estimate. You're going to divide the whatever you need to start. Now, look, I'm going to give you an example. The you try it is going to be a little bit different. I want you to think about this a little bit differently because you might not always have a two-digit quotient. Okay, why don't you give this one a try? Okay. So we're going to start, and we're going to do our estimate. 467 divided by 50. Okay, so I'm going to leave my 50 as a 50. And I'm going to think to myself, what can I round that 46 to that makes it compatible with 5? 45 does, right? Because numbers that end in 5 or 0 are divisible by 5. So my basic fact is 45 divided by 5 equals 9. 1 0 minus 1 0 is no zeros. So now I know my answer is 9. My answer is going to be close to 9. And most likely it's going to be a one-digit quotient. Sometimes when you get answers, when you get estimates that are on either side of that one, like 9, maybe because of your estimate, it really should be, your answer might be 10, but I'm going to think about this as being a one-digit quotient, which means I'm only going to have a number over the ones place, right? So when I divide, so again, I'm going to divide, multiply, subtract, and check, right? So I'm going to think to myself, I'm going to just make sure when I do this that I'm right, because 50, this I can't go into 46. So you know what? I know my estimate is right, and I know that it is only going to be a one digit because I can't have, if I put a 50 there, right? It wouldn't work. So I know my answer has to be. I knew that was going to happen. I knew that my answer has to be a one-digit answer. So, how many times does 50 go into 467? That seems like a daunting task at first, right? Except when you start to think about it, what times 9, what times 5 is close to, somewhere close to 46? Well, 9 times 5 is 450. We kind of identified that over here, right? So I'm going to put a 9 here. Ah, that's no good. There we go. Because 8 times 50 would be 400. That would be too low. 10, we can't do 10 times 50 because that would be 500. 500 would be too big. So I'm going to try 9. And there is a little bit of guess and check when it comes to this. It's like educated guess and check when it comes to this two-digit divisors. You're not always going to know. It's not always going to come to exactly what that answer is. You may actually make a. In fact, let's go ahead and just do something for it. I want to make a mistake here. I'm going to make a mistake on purpose. Say I did this. 8 times 50 is 400. Okay, so I multiplied. Now I'm going to subtract. I'm going to check. 67. Is 67 less than 50? No. So now I know that that is too low. So let's go up to 9. So 9 times 50 is 450. And then we're going to subtract. Oops, that was weird. Come on, go away. 7 times 0 is 7. I'm 7 times. 7 minus 0 is 7. 6 minus 5 is 1. Now 17 is lower than 50. So I know I'm okay. One thing I think people have to get used to, when you get two-digit divisors, now you can have two-digit remainders. And I think sometimes that kind of people think that's wrong. Like, I've got a two-digit remainder. It can't be right. But you can have a two-digit right. You can have anything up to the number 49 could be a possible remainder when you're dividing by 50. As long as it's under 50, you're okay. As long as it's under that divisor. So you can easily have a two-digit remainder. If you were doing three-digit divisors, you could have a three-digit remainder. So I think we're so kind of programmed to having one-digit remainders that we figure that's not possible. But now, see, anything 49 or lower would work as this. So now we have an answer of 9 remainder 17. And you express that as 9 remainder 17. You could also express that as 9 and 17 over 50. And that is how you divide two-digit divisors with multiples of 10. Thank you for listening.